So I didn't do an amazing job with my blocks talking about actual hang time. So I gave a load of equations last class, and all of those equations are important. So, and that was in my last set of notes, but I'm going to show you here. There are all these equations in the last set of notes. Every one of these sets of equations that you wrote, I'm going to highlight them now. You need to put them on the back of your notebook. So this and this is equal to this and this. This and this. This should go in the back of the notebook. You may not write that stuff. This can go in the back of the notebook if it isn't with this. Remember, leave a lot of space. Write this small. This. All right. Okay. What I'm going to review with you today, so pause this video now and please put it in the back of your notebook, everything I just highlighted. And what confused people is like, okay, there's a lot of stuff going on here. What I'm going to detail a little bit more is how this all plays out when it comes to hang time. So I'm going to just add to these notes. I didn't remind you guys to actually like take notes on this. Not take notes, but summarize it. So free fall versus hang time. Told you, lots of notes, and I probably should have done this, given a little less time to do work. So free fall versus hang time, what I would like you to know. When you're free falling, we usually free fall is referencing one direction. So free fall is usually meaning one directional. Okay, I'm going to label this FF for free fall. And then hang time is free fall in two directions. Hang time is free fall in two directions. Okay, so when I say that, I mean you lifted off the ground, you defied gravity, negative g, went in a negative direction, and then you came back down. Okay, first thing I need you to realize, free fall, if you just fall off a cliff, your VI will be 0. Your VF will be something. Other things that you have to know for an equation like this is either distance or height. I'm not going to put the slash. Height or distance. Or you could know the time elapsed. Okay? And again, that would be T initial, in this case would be 0. T final equals 8 seconds. Okay? So when you're working with all of these equations that I just rambled on about, you need to identify the variables that have been given in this equation. So this is just free fall. So free falling. This all is dealing with free fall. All right. So if you have a time, so here's the time that's been given. The T initial is 0 and the T final is 8 seconds. And you have an initial velocity of 0. Are there any equations? So here are my numbers. So the change in time equals 8 seconds. Let's see, is there an equation with time and v initial? Now I can solve for distance. Look, wait a minute, I don't know my acceleration, do I? So I know time and I know vi. I actually do know a. When we're free falling off of a cliff, what do I always know? I know gravity is 9.8 meters per second squared. So remember I said use the KNEW strategy. No, I know VI is 0, V final is unknown. I know T is 8 seconds. And I know G, because I memorized it, is 9.8 meters per second squared. So I can now solve for distance. Distance is VI plus 1/2 GT squared. Now if I plug in the numbers, I have D, which I don't know. Okay, so that's the next thing. What do I need to know? I need to know the letter D. What is my equation? It's here. What is my work? Here we go. Distance is equal to 0 meters per second plus 1/2 10 meters per second for the ease of math, 8 squared. So my next line would be D equals 5 meters per second squared times 8 times 8 is 64. And then D is 5 times 64. I'm not going to pause the video to find that. But that's how you would solve for free fall. Okay, well, what about this hang time nonsense? Okay. I told the last class, or I told both classes, that hang time is free fall in 2 directions. In 2 directions. So if I have, I'm going to do the ballerina problem. So this is number 11 on page 22 of the Take Back packet. Okay, it says a ballerina leaves the ground at a velocity of 1.8 meters per second. Okay, well, I only have an equation for one directional motion. I only have a free fall equation. So I'm only going to pay attention to one direction of her motion right now. When she reaches the peak of her jump, so her VI is equal to 1.8. Her V final at the peak of her jump, when she's reached the highest point she can go, is 0. Because she's stopped and she's switching direction. She is now getting ready to fall back to the ground. Okay, the other things I know, so let's work through my K, N, E, W. Okay, my known is VI is 1.8 meters per second. My V final is 0 meters per second. My gravity, what did I tell you about moving upwards? When I move upwards, my gravity is negative. So in this case, gravity is a negative 10 meters per second. All right. So what do we need to know? We want to know her distance. No, I think it's asking for time. I want to know time. I can't remember. It's time or distance. So I'm looking for an equation with VI, VF, G, and T in it. Does not mean it's going to be equal to T. I'm just looking for an equation with 1, 2, 3, 4 of these, all 4 of these variables in it. So if I scroll up and I look at the equations I was given, wait a minute. No, not that one. 1/2 G. I don't have time. Not that one. No, it's not D equals 1/2. I'm looking for No. Wait a minute. This one. This one has what I'm looking for. It has all the letters that I need. Remember, A can also be replaced with G. Okay, so I'm going to rewrite this equation down here. I have VF equals VI. Oh, gotta go back up and read it again. I don't even have them memorized. Plus AT, plus AT, plus AT. Beautiful. Okay, now it's time to work it out. VF equals VI. Yes, I would expect you to rewrite it. Plus AT. Then V final is 0 meters per second. VI is 1.8 meters per second. Plus A, we said, is negative 10 meters per second squared, my bad, times T. I don't know T, so I'm just going to leave T in here. Okay. So the first thing I want to do is get rid of 1.8 on both sides. Negative 1.8 meters per second. So now I have negative 1.8 meters per second equals negative 10 meters per second t, right? How do I get this by itself? I divide by 10, negative 10 on both sides. I keep forgetting the square. I apologize. Divided by 10 meters per second squared, and it's a negative. So I end up with a time of 0.18 seconds. Okay, we ain't done. This is just for her to get to the peak. This is time it takes to get to the peak. How long is it going to take her to go all the way up? 0.18 seconds. And come back down, 0.18 seconds. So your total hang time, this is time of free fall, it would be 0.36 seconds equals T of hang time. Okay, with a little bit more explanation, take some time and work through these problems some more. You will have time in class to work on it. And then next week, we will do some review and start on a graphing assignment that will be a big assignment that we'll be working on throughout the rest of class. All right, thanks guys.